Okay, guys, so let's start. So let's before I start the new topic today. So let me summarize what I did, guys. So this chapter, in this chapter, I'm explaining how can you program input-output devices here on the board, okay, using both C and assembly. That's what I did, okay, in this chapter. So I already explained how can you program the LEDs. We have 8 LEDs as I explained. I told you they are connected to port B, okay? And also you have to use BJ because BJ1 is the enable as well. Also, I told you the 7 segment, they are connected to port B as well. And we have to use port P for enable. That's what I explained. Last time also, so I also explained how can you make delays, how can you make a delay, okay, this way. And maybe this is, later we are gonna do also delays using another ways. Later I'm gonna tell you how, but anyway. And I also explained how can you make a square wave easily, okay, so very easily you can make a square wave, that's what I explained. And in the coming lab, you are gonna create a number of square waves like this one, and you are gonna see it in the scope. So this is also I explained this program. How can you send some data serially? And also the coming lab we have something like that in the coming lab. Okay. Also last time I explained how can you use the switches. So here we have switches here, 8 switches as I told you. They are connected to port H. That's what I said last time. Only what you need to do is I need to know the switch is connected or not, right? So and the way you programming wise, just different programming wise, you have a byte. You need to check if the bits are ones or zeros. The bits are zeros, that means the switch is connected. The bits that are ones, that means the switch is open. Okay. And once you check if the switch is connected or not, you need to do something, because if the switch is connected, I have to do something. If the switch is not connected, I have to do something else. As you will see, I'm gonna put it in a program and you will see. Okay. So that's what I explained last time, right? Yeah. Also, I explained RGB. This one, this LED that can give 3 colors. We're not going to use the RGB in the coming in this week, but we're going to use it next week. Okay. So next week lab, we're going to use the switches. We're going to use the RGB next week. Also, we're going to use the LEDs. Okay. Anyway, so today I'm going to start with the buzzer. Here we have a buzzer here, very interesting topic. So I'm going to start with the buzzer. As you see here, guys, we have, you can see this one here. Okay, let me put it here. We have a very interesting stuff, and programming wise, they are easy. Nothing is new. Similar, exactly. Programming is very easy, similar to what we did before. Okay, so so here, this is what we call buzzer. Okay, by the way, if you have a sticker like this one, remove it, because this sticker you're not going to enable, you're not going to hear the sound if you, so remove this sticker if you have it. Okay, so this is a buzzer. This buzzer is used if you want to make some sound, and if you see the project, the student did before, some students make some sound, like some sound for songs, something like that. You can look at the project. Okay, I'm going to tell you how using it. For sure, the quality. This is a very cheap, very simple device, right? So don't expect the quality is gonna be too good, but still it can be used in many applications. Okay. So number one, how it is connected. How can we program it? How can we generate sound? That's what I'm gonna explain today. Very interesting, very easy stuff. Okay. So I'm gonna tell you how. Number one. Okay, how this device is connected. Okay. So this is the microcontroller. We have here what we call PT5. Okay. So the buzzer it needs only one pin. It's connected to the buzzer. That's it. So the buzzer needs only one pin. This pin is PT5. So the buzzer is connected to PT5. Is that okay? This is how it is connected. That means in the programming, I shouldn't tell you, but for programming, you have to configure BT5 output. Yeah. So programming wise, I have to configure BT5 output. Is that right? Okay. Now, this is how it is connected. Now, how I can generate sound? How can I generate sound? I'm going to tell you how. Very easy. Okay. So the idea is that. So all what you have to do here, guys, you have to generate a square wave. That's it. So if you generate a square wave here, you can generate sound. Oh, that's very easy. I already explained how can we generate a square wave. That's it. So all what you have to do, you have to generate a square wave here. Okay. Once you generate a square wave, you can create a sound. That's it. Very easy, right? But what frequency? This signal is that can be any frequency? No, there is a limit. Okay, because our ears. I'm not sure if you know this. This is somehow very interesting stuff. Okay, I'm gonna tell you a very interesting story. I'm gonna tell you about it. Look here, guys. Our ears, our human ears, we have only certain band of frequencies we can hear, right? So I think it's usually between 2 hertz to 20k hertz. Okay, so this is the range of frequency we can hear. More than that, we cannot hear. We cannot hear frequencies outside this range. Is that okay? Okay, I'm gonna tell you some stuff really very interesting. Okay, number one. Oh, as we get older, we cannot hear higher frequencies. Okay, so children can hear some frequencies we cannot hear. Is that okay? Okay, that's why there are. If you search online, there are some websites that can determine your age from the sound. So if you search online, there are some website. This website is gonna generate some sound, and it's gonna ask you, do you hear it? If you say yes, it's gonna give you your age. Okay, because every age there are some frequencies you cannot hear. Is that okay? One more thing is, I remember I read one time in the news in South Korea, they had a problem. Like teenager used to gather somewhere and make a lot of noise, make some trouble to the resident, to the people. Okay, so what they did, they used a buzzer, but for sure maybe a very strong buzzer. This buzzer to generate some noise. Okay, older people like us or grown-up people are not going to hear it, but the teenager can hear it, so it's going to be like very noisy place for them. So they can go away and don't make trouble. Okay, so I read it in the news anyway. One more thing, you may be familiar with it. There are some devices, if you put it in your house, as mice, mice can go away, rodent. Okay, so the rodent are gonna go away. Okay, actually, how these devices work? The way these devices work, these devices generate some sound. Okay, with some frequencies, high frequencies. We don't hear these frequencies, so we don't hear it. Okay, so it doesn't make noise to us. But for the mice or rodent, when they hear the sound, it's gonna make some noise to them, so they can leave or go away. Is that okay? I remember in one semester, it was somehow interesting. In one semester, we did test two. Test two was like some kind of project. The student did project, and what they did, they changed the frequency of the buzzer. Okay, and it was somehow funny because imagine someone can hear the sound and you cannot hear it. You got upset. Someone told me my kids were able to hear some sound, but I was not able to hear the sound. You got upset. But anyway, is that you understand what I'm saying? Okay. Anyway, so the conclusion is this is the conclusion. Somehow it's very interesting, very nice story. But the conclusion is we have a buzzer that's connected to BT5, and then if you want to generate a sound, all what you have to do, you have to generate a square wave. Very easy. I already explained how can you generate a square wave. Very easy, very trivial. Is that okay? But you have to select the frequencies correctly because some frequencies we cannot hear. Okay, so you have to select the frequencies. One more thing, the people who did songs, how they made songs using this small buzzer. The way they did it, every tune, I'm not good in music, but in music we have some tunes, right? And if you wanna run a song, if you wanna make a song, you have to use the tunes, right? So every tune should have a certain frequency. Got what I'm saying? So this is the way how they made the song. So they generated a square wave with a f1, a certain frequency for a certain time, okay, to make tune one, and then they can do another tune, so that you can hear a song. Is that okay? Very easy. All what you have to just change the frequency to run different tunes. Is that okay? And let me. I think I have a project here. Maybe let me. So if you go to the course website, I think there was a very nice project. It was about a hidden piano. Let me see, what is it? It's yeah, this one, very interesting. This one.
This is Rodrigo today, and this is our visible piano using the HCS12 gravity board. So what we have here is an ultrasonic sensor, which is going to emit a signal, and when it hits the object, it will come back, and it will read the time that it took to come back and display the distance.
So what happens, you have a sensor here. I'm going to explain later how can you use it. Using this sensor, you can measure the distance from the sensor to this box, and then you can display the distance here. And based on the distance, you run different tunes, right? That's why it acts as piano, because when I change the distance, I'm going to change the tune, because you'll see it. Very interesting.
See, now it's showing that to play the sound that corresponds with the distance. So now it's playing F3. As you move it out, it plays different notes.
Can you hear it? Can you hear the different notes? Okay.
See, that's B4. You go all the way out. So here, come all the way back. You can pause the sound at any time with this button or turn the system off with PH0.
Anyway, it's interesting. So how they make different tones? As I told you, they just change the frequency. Very easy. And how you change the frequency? Very easy. All what you do, just change the delay. That's it. You got what I'm saying? So if I change the delay here, if I change the amount of delay here, I can change the frequency, right? Because frequency should equal 1 over t. And t is the time from here to here. This is the period or time. Is that okay? And we assume they are equal. We assume this one is equal to this one. Okay, that's what I'm going to explain in next lecture. In next lab, we call it 50% duty cycle. So 50% duty cycle means it's equal. So this is t divided by 2. This is t divided by 2. Okay, so by changing the delay, you can easily change the frequency. That's what I'm going to do now. Is that okay? Any questions? Okay, guys. Okay, so let's see. What program? Very interesting program. We are gonna run it now, right now. Yeah. Look here, guys. So okay. So again, let me summarize. How can you program it? To program it, you need to do two things. Number one, you need to configure BT5 output. This number one. Number two, you need to generate a square wave. That's it. Okay, and that's very easy, right? So now I want to make a program. I want to generate a square. I want to make a police siren. Police siren. Okay. If you see the police siren, how the police siren looks like? It's two tones. Right? It's two tones. So this is what I'm gonna do now. So I want to make the police siren. It's two tones, two different frequencies. So I'm gonna run the first frequency for half a second, and then I'm gonna run the second frequency for half a second. That's why if you hear it, so every tone should be for half a second. Okay, that's what I'm gonna do now. Okay. So what I'm gonna do, I wanna write a program to generate two tone siren, which is the police siren, that alternates between 250 hertz and 500 hertz. So I'm gonna use 250 and I'm gonna use 500 hertz to generate. Each tone is gonna last for half a second. So I have to run this one for half a second, and then I'm gonna run this one for half a second, and then I'm gonna come to this one half a second, and then I'm gonna come to this one half a second, and so on. Is that clear? 250 and 500. Is that okay? So if you look at the scope, if you want to see the signal in the scope, this is how the signal should look like. The signal should look like some frequency this way for half a second. Okay, and then higher frequency for half a second. Okay, so yeah, because we have 500 hertz and then we have 250. Yes, if you look at the scope, if you see the signal at the scope, you can see high frequency, 500 higher, and lower frequency. This one for half a second, this one for half a second. So, yes. Yeah, that's a very good question. No, it's the same volume. Because again, this is a very simple device. If you look at the project, one semester, one student bought like amplifier, put something like amplifier, and you put something more complicated, and he got like a speaker. So he added speakers. It's going to be more complicated than that. Okay. Again, I want to tell you something, guys. This signal, this buzzer, is not designed to make the songs. I'm not going to use this one to make songs, right? Okay, so how in real life, how can you use this one? I'm going to tell you how. For example, when you scan your car on the door, you hear something like beep, right? So just to notify the user, it is done. This is perfect for something like that. Okay, just to give you some notification. You got what I'm saying? So, but I'm not going to use this. Is a very simple device. You got what I'm saying? So it's just simple. It's used for when you want to just make a notification to the user, right? If you want to make something stronger sound, so in this case, you have to use amplifier. You have to connect to the mic. So it's going to be more power. You need more power, but it's doable for sure. But anyway, but again, we are talking about very simple systems. Okay, guys. Any questions? Okay. So let's see how can we do this program, and also I'm going to show the video as well. It's very interesting. So I'm going to show how we are going to make the program. So look here, guys. Number one, as I told you, you need to configure BT5 out. Yes, that's true. Okay, this number. Number two, if you look here, guys, what I'm going to do, this part from here to here should generate 500 hertz for half a second. And so this is half a second. 500 hertz for half a second. And this part of the code should generate 250 hertz for half a second. So from here to here, it's going to take 1 second. And then I'm going to go back to here so that I repeat again. I'm going to tell you how. This is how it is. This part should generate 500 hertz for half a second. 250 for half a second. And then I'm going to repeat that. So from here to here, it's going to take 1 second. I'm going to tell you how. Look how it is. Look, guys. Number one, in order to generate 500 hertz, is that okay? So the period T should equal 1 over F, should equal 2 milliseconds. Okay. So from here to here, it has to be 2 milliseconds. 2 milliseconds, it should make 500 hertz. Is that okay? So that means the delay here has to be one millisecond, and this one should be 1 millisecond to generate a signal like this one. Okay, and that's what I did. Look what I did here, guys. Here, high, pull BT5 high, wait 1 millisecond. Okay, wait 1 millisecond, and then pull it low. So it's gonna be high. I'm gonna wait 1 millisecond. Pull it low, and then wait 1 millisecond. So from here to here, I'm going to generate 1 cycle. Is that okay? 1 cycle. High, wait 1 millisecond. Low, wait 1 millisecond. This part is going to generate only 1 cycle. Is that okay? This cycle should be 500 hertz. Okay? But I want to keep it for half a second. So I want to repeat it for half a second. Is that okay? So how I can do that? I'm going to tell you how. Very simple. I'm going to tell you how. So the way I'm going to do it is, from here to here, it's going to take 2 milliseconds. Is that okay, guys? 2 milliseconds. So this is 1 cycle. So one cycle is going to take 2 milliseconds. Okay. So if I want to generate half second means 500 milliseconds. Is that right? So how many cycles I have to generate here? How many cycles? Okay, so I have to generate 500 cycles. I'm right? No, 250, right? I'm sorry, 250 cycles. Why? Because 250 cycle, because if you multiply this one by 2 milliseconds, you are gonna get 500 milliseconds, which is half a second. Is that okay, guys? So that's exactly what I'm gonna do. So what I'm gonna do, I'm gonna generate this signal, okay, 250 cycles. And this is gonna make half a second, okay? That's exactly what I did here. Any problem with this calculation? It's very simple, right? So let me, yeah. So if you see here, guys, so this part from here to here, this part from here to here, okay, should generate one cycle, okay? So this is one cycle, this part, okay? Then I'm gonna make a loop. Can you see this loop, guys? So I'm gonna repeat this part. So from here to here, this is a loop for 250 times. Is that okay? So I'm gonna repeat this part 250 times. Every time I'm gonna do one cycle. Is that okay? By this way, I'm gonna generate 250 cycles. And 250 cycles means half a second. Is that okay? Any question? Okay. So once I'm done with this second, I'm gonna come to the second piece. I'm gonna repeat exactly the same thing, but I'm gonna change the numbers. But I'm gonna repeat the same thing. For example, here I want to generate a signal 250. So the frequency, period t should equal 1 over 250 hertz, which equal 4 milliseconds. Okay, 4 milliseconds. That means this one should be 2 milliseconds, and this one should be 2 milliseconds. So number one, I have. So if you look here, guys, this code I'm gonna use this code again, but I'm gonna change the delay from 1 millisecond to 2 milliseconds. That's number one. Okay, because this signal, the delay here has to be 1 millisecond. The delay here has to be 2 milliseconds. So I'm gonna change the delay from 1 millisecond to 2 milliseconds. Is that okay? Also, if I wanna run this signal for half a second, so how many cycles I have to repeat? Here it has to be 125. Okay, it has to be 125 cycles. That okay? Because every cycle should be 4 milliseconds. So every cycle here, every cycle 4 milliseconds. This is for one cycle. I wanna run it for half second. Half second again means 500 milliseconds. So if you divide 500 milliseconds by 4 milliseconds, I think it's gonna be 125. So I have to repeat this one 125 times. Okay, any question? It's the same thing, but I just changes the numbers. Okay, so if you see here, guys, by this way, so here, so if you see here, guys, this part from here to here, this one is gonna generate only one signal, one cycle. Okay, so I'm gonna repeat. This is a loop. This is for loop. So I'm gonna repeat this part 125. Is that okay? So this part is gonna take half a second, and then I'm gonna branch back to the beginning again to repeat it. Is that okay? Any question? Okay. So you're gonna hear two sounds. Half a second. Okay. Let me ask you a question. Again, I'm just playing. I enjoy it and I'm playing. Okay. What if I do something like that? I need you to think about what would happen. Here, this one, I'm gonna cut it in half. For example, this one should be 125. I think this is a half. This one also, I'm gonna cut it in half. So for example, I'm gonna put it 60. For example, 62 or 61, something like that. So if I cut this one in half and cut what this one I have, what do you think? How the signal will look like? Still, I'm generating two tones, but I change fast. I alternate them fast, right? because I reduced. Now it's a quarter a second, right? So how it's going to be like, you know, when you have a signal, but the signal looks like urgent, more urgent, okay? Something is going, something like more, very urgent. You know what I'm saying? That's what you will see in the video now. So by this way, very easy. You can just change the numbers. You can, so that's what I'm saying. So let me say it again. So here, if you go have a second, you have a signal something like that, right? But if I make it shorter, so it's going to be something like more urgent, thing, like, very fast because I change it very. Is that okay? Any question? Again, you have this this program here. You can run it. I'm sure it's working. And then I'm going to show you any question here before I show the video and before I go to the C language as well. But I'm going to show the video first. Okay. So let me show you the video.
It's a Sayeri program. Is 250.
So here, this is the original one, 250 and 125, the original one. I'm going to change them later. I'm going to cut them in half a little bit later. So let's run this one first.
100.
Okay.
Let's run this one.
Two tones, right? Two tones. Everyone have a second.
Now let's make the tone shorter.
So every tune I'm gonna make it shorter. So I'm gonna cut these numbers, I think, in half. So this one, no, it doesn't need to be exactly half, but I'm gonna make them shorter. So this one was 250. I'm gonna make it. Oh, so let me stop here. So this one was 250. I made it 100. This one was 125. I made it 50. So I made it less. It doesn't need to be half, but I want to make it faster. So you'll see how it's going to be like.
You will see the result.
So I'm going to run now this one. You can see the difference, right? Okay, any question? Okay. One more thing, I remember in one test, in one final exam, I did the following. It was like some security system. So the user is gonna enter a PIN number story. It was like a story, okay? And then if the PIN number is correct, if you enter like you have to type a PIN to open a door, to enter a room, okay? So if the PIN number is correct, I wanted to notify the user. When you scan, when you slide your card, if it's already went through or approved, you do something like beep, something like that. So I asked the student once if the PIN number is correct, okay, just to give a notification to the user, so to tell the user, I opened the door, now you can get it, okay, something like that. So the way I said it, I told the students I want to generate 500 hertz for I think 25 seconds, okay. For sure, that's not difficult. This is similar to what I explained right now, right? But you're not going to alternate. So it's not like alarm. It's not alarm. You're not going to alternate. It's just one frequency, just one tune for 25 seconds. So I'm going to give you just one tune for 25 seconds. Is that okay? So it's to be the same thing as I explained right now, but there is a small difference. Okay, what is the small difference? A small difference is for 25 seconds, okay, every tune, if it is 500 hertz, so it's gonna take 2 milliseconds. So you need to count how many times you have to repeat this loop, right? So you need to count, divide this one, you have to divide this one by this one, and then you need to know how many cycles you have to do. So you have to create for loop. You already know how to create for loop, even if it's for a big number, even if the number too big. I don't know, you need to calculate it, but even if the number is too big, like 100,000, still you can do it. I already explained how to do for loops, okay? Anyway, so what I'm gonna do now, I'm gonna explain the same program, but in C. So it's gonna be everything almost the same. but I'm gonna use the format of the C language. Okay, so let's see how I made it. Look here, guys. Number one. Number one, you need to configure BT5 output. That's number one. So this is how you configure it. Okay, so you have to be output. So you have to set 1 bit. So here I have to set bit number 5 here. Okay, because we started from 0, and this is bit number 5. So you have to set this bit. This is number 1. Okay. Number 2, as I told you, I need full loop for 250. Is that okay? So I need full loop for 250. I need another full loop for 125. Is that okay? So 250 here, as I did here, 250 loop for 250, another loop for 125. That's what I did. Okay. So this is the first loop here, 250, and here in every iteration, I'm gonna generate one signal, only one signal in every iteration. Okay. So this one here, I'm gonna make BT5 1. I'm gonna pull BT5 high. Okay. This one using OR, so I'm gonna make it high. Then I'm gonna wait 1 millisecond. Exactly the same thing. Nothing is new. So here I'm gonna wait one millisecond, and then I'm gonna pull it low, and then I'm gonna wait 1 millisecond. So this one is gonna generate one interval. So I'm gonna repeat this one 250 times. Is that okay? Same thing here, but the signal is different because here the delay is 2 milliseconds. And then I'm gonna repeat this part 125. And then once I'm done, I'm gonna go back to repeat again. So this part is gonna take half a second. This part is gonna take half a second, and then I'm gonna repeat again. Any question? Is that okay? Is that difficult? Okay, if you have any question, raise your hand. Okay, let's move forward. Okay, now, what I wanna do now, guys, I wanna use a switch. So I'm gonna explain to you a program right now. I wanna use a switch. Okay, this switch should turn the alarm on and off. So if I turn the switch on, the alarm is gonna work. Okay. Once I turn it off, there is no alarm. You got what I'm saying? So this should give you an example. If you have something working, like for example, a very smooth system, like the buzzer. It's working. How I can use one switch like on off. So this switch works as on off to turn the system on and off. I'm gonna show how I can do it. Okay. So what I'm gonna do, I'm gonna use the same program like this one. So I'm gonna use the same program, but I'm gonna modify this program. Okay, I'm gonna tell you what is the idea here. Let me put it here. So what I'm gonna do is the following here, guys. Can you see this program? What happens in this program? Okay, so before I choose the code, let me tell you the logic. Very easy, very easy. So I'm gonna use the same program, but I'm gonna do little modification. I told you guys, this one is gonna take half a second, and then half a second, right? And then I'm gonna go back to repeat again. Is that okay? So I'm gonna do a very little modification. The modification I'm gonna do here, I'm gonna put something like if statement here, something like if statement, okay? So I'm gonna say if the system is on, okay, go here. Else, go here, keep repeating. You got what I'm saying? So if I can do something like if statement here, again, I'm explaining the logic. I'm gonna tell you how. So if I do something like if statement here, I'm gonna check the pin. The switch. So you have a switch can turn the system on and off, okay? Or can turn the buzzer on and off. Okay, guys. So here this is one way to do it. I can put here a condition, okay? So here if the system is on, come here, okay? And then if the system is off, just wait. Keep checking here. So I'm gonna wait here. Is that okay? That's exactly what I did in this program. So if you look at this program, guys, this is exactly similar to the program I just explained right now. I just added two instructions. This instruction here to configure port H as output. This is not the configuration. Also, I added this one, as you see here, guys. Look how this one is here. So here I'm gonna check the switch. If the switch is connected, that means the system has to be off. Here I'm considering connected means off. So I'm going to keep looping here, right? So I'm not going to come here. Here I'm going to branch three. So this bit is here, if the switch is connected. To me, that means the system should be off. So I should not leave this out. Okay? The way I did it, if it's connected, I'm going to keep looping here. So I'm not going to come here. Because I don't come here, that means you're not going to get anything. There's no sound. Is that okay? So I'm going to keep looping. I'm going to keep looping here until you turn the system on. Once you turn the system on, I'm going to come here, okay, and then I go check again. Come here and go check again. Is that okay? You got it? Any questions? You got it? I'm going to tell you something, but you can tell me if it is true or false, okay? So based on the design of this program, we are going to check the switch every half a second. Every 1 second. True or false? So here I'm going to check the switch. Is that on or off? Here, after 1 second, I'm going to check the switch every 1 second. Is that true? Because we check here. If it is on, I'm going to come here, and after 1 second, I'm going to come back to check again. So I check every 1 second. Is that okay? This is how the program is. I'm saying this is the program, right? This is how the program is. Okay. So now, let me ask. That's what you are going to observe. That's what you are going to observe in the video. Okay. Let's I change it. What if I change the switch here? So the system was on, and at this point I made it off. What's going to happen? It's going to work for some time until it turns off, right? So there is a delay. That's true. Okay, that's true. So that's what you will see in the video right now. But for sure, because it's just 1 second, it's going to be hard to notice it. But you can notice it. You can notice it. You can what I'm saying? Again, it may not be big deal. It's something like that. I'm not saying this is. I'm not saying this is disadvantage. I'm not saying that. Okay, I'm not saying that. I'm saying this is how the program is written. Okay, this is how the system is going to behave. That's what I'm saying. Is that okay? So that's what you should notice in the video, because I check every 1 second. So you will notice once I turn off. Okay, let me put this way and tell me if it's true or false. Okay, if the system is off and I want to turn it on, there is no delay. It's going to turn on right away. But if the system is on and I turn it off, there may be some delay. True, right? Because if the system is off, so I check here. I'm here. I'm checking. Once you turn it on, I'm gonna come here right away, right? So once I come here, I'm gonna check every second, right? So maybe there is some little delay. Okay. Again, I'm not saying this disadvantage. I'm just saying this is how we did the program. This is how the system will behave. It may not be a problem. It may something. It's not less than 1 second. The delay is not big deal, right? Or it may be a big deal in some applications, right? So that's why you have to do it in a different way, okay? But I'm just explaining how this program can work. But for sure, there are other ways, right? But this is, okay. Any question? So let me tell you the conclusion, guys. Number one, what I want to teach in this program, how can use one switch here for on-off. How can you use one switch for on-off, okay? So like you have a system, so this switch can turn the system on or off, okay? For sure, this is a very small system, right? So it's just a buzzer, okay? Or just alarm system, okay? So this is the way I did it here. This is the first thing you should do. Second thing, you should also think about the delay. The delay I'm going to create here. It's just very, very little delay. I'm going to run the video, and you will notice. But for sure, if I don't tell you, you may not notice. You may not notice it. You will not observe it. You may not notice that there is some delay, or if I don't tell you, okay? But anyway, you will see the video. So if I turn it on and off first, you will see some delay, okay? And this delay should happen when you turn the system on. But if the system off, when the system moves from on to off, there will be delay. But from off to on, there is no delay. Yes. What delay? Yeah, that takes some time. To execute it in instruction takes time. Okay?
So it's not going to be like exactly 25 after that milliseconds.
Yes. Yeah. Yeah. So let me. I'm not sure. I'm not quite sure if I understood your question, but let me put this way. And I explained last time. Okay. So here, I turn the signal high, right? At this moment, right? And then I want to wait 1 millisecond. So to do that, I'm gonna call this function. This function is gonna return back to me after 1 millisecond. Is that okay? And I told you this function is not very accurate because just to make it simple, I ignore the execution time of some instruction. So I didn't count this one. I didn't count this one. I didn't count the return. So 3, 4 instruction. Yeah, 3, 4 instruction I didn't count. But these instructions, listen to me. So these instructions, the execution time is very little. So actually, I want to create 1 millisecond. Okay. Again, guys, look here. Next time, you have the board, you have the program, right? You have the scope. Next time, I'm going to give you a scope. You can do it. You can make a delay 1 millisecond, and you can measure it. Is that 1 millisecond, 12 millisecond, or maybe a little bit more. Okay. It's actually a little bit more. I'm not sure even if you can see it on the scope or not. I don't know. You can try. Because if it is 1 millisecond and the full instruction, I'm gonna have like how much? It's gonna be too little because 1 microsecond you need 24 cycles. For 1 microsecond you need 24 cycles, right? Assume in the worst case, okay, the instruction I'm gonna ignore. They are gonna create 20. They are much less. But assume it's 24 cycles, okay? That means in the worst case, I'm gonna make 1 microsecond. Imagine 1 millisecond, I'm gonna add 1 microsecond to it. It's nothing, right? Right? It's nothing. You got my point? So it's still, I can say it's 1 millisecond, okay? For sure, if this 1 microsecond in some application, it can make a difference. For sure, I shouldn't do it this way. I have to find another way. But here in this application, because you are making a sound, if I make a delay, if there is error in the delay a little bit, that's okay. We're engineers, okay? Engineers means in many engineering problems, there are some tolerance to errors, okay? But again, I'm not saying it has to be this way. I'm not saying that, okay? But there are other ways. If you need exactly 1 millisecond, you can do it. But there's another ways. For example, what I can do here, instead of using a function, I can write here some instructions, for example, or I can count what is the difference here, and I try to compensate this the instruction or you can write the instruction here. So there are other ways if you need exactly 1 millisecond. Is that okay? Any questions? Okay. So let me show the video first before. Yeah.
Let's find this program. Okay, the siren is working.
Did you see? Did you notice the delay now?
Yeah,
okay, let me do it again.
Now it's off. So here I'm going to use the fill.
Try to see the delay. Okay.
This button has on the off button.
No, I think okay. Let me. There was a very clear delay in the beginning. So let's see. Look now. See now.
The siren is working. Now it's off. So here I'm going to use the first button.
No delay.
On the off button.
Once you turn it on, no delay. Right away. This by accident, there's no delay because when I turn it off, it was at the end of 1 second because we check every 1 second. You know what I'm saying? So it depends on where you turn it off. If I'm gonna check here and you turn it very close, so gonna be you're not gonna even observe it. That's what you say. there is a delay here. Little, very little.
Delay because we check the status of the switch every 1 second. No? Sometimes.
I'm trying to make it.
Some delay.
I want to make the delay, but I can't. Okay, guys, any questions? Okay, now I'm gonna teach how can you do the same program in C. Okay, it's gonna be exactly same thing, but as you see here, guys, what I did here. So this is the siren program. Again, I'm gonna add 2 instruction. This one instruction here to program port H as output. Okay. Number 2, I'm gonna put this condition here. I'm gonna put this condition here. So if the switch is connected, come here. Okay. If not, don't come here. You got so here. This is the siren. This is the police siren. This is the siren put. I'm gonna put it inside this statement. If the switch is connected, come here. If it's not, don't come here. Is that okay? So let's see how we wrote this one. This one, you may be confused because I put this one here. This is like PTH, right? So if I say PTH and you do end, you check if the bit is 1, okay? Of this, so if the switch is 1, come here. If 0, don't come here. Is that okay? So this is a function. This is one of the function we have. This function is called switch1 underscore DIB. This function actually is going to return PTH. So it's the same. If you want to use the function or if you want to use PTH, it's the same. Just this function is going to return PTH. Any question? Okay, guys. Okay. So the next topic, as I told you guys, I'm not going to explain. I'm not going to follow the same order because I need to cover first what I need in the labs first. Okay. So that's why this 7th segment, maybe I'm going to delete a little bit because I may not need it now. Okay. The next thing I'm going to explain is any questions so far? So what I explained so far, guys, is you should know how can you program LEDs. That's what I explained. You should know how to make delays. That's what I explained. You should know how to use the switches, how you use RGB. Okay. How you use the buzzer. That's what I explained. Is that okay? Now, what I'm going to explain right now, guys, I'm going to explain. We have 4 push buttons. Can you see the push buttons here? Push buttons. So we have 4 push buttons. Number 1, like that's always what I do, guys. Number 1, for any device, I have to tell you, number 1, how it is connected. Number 2, how can you program it? It's the same thing. So I'm going to tell you how this push button is connected and how can you program it. And how it is different from switch. It's different because this push, you connect. Okay, listen to me. For the push button, when I press, I connect. Once I release, disconnect. Switch is completely different. Switch, one direction is connected all the time. The other direction is disconnected all the time. So this one is gonna connect momentarily. Momentarily. Okay? So it's gonna connect for some time, and then once you leave, it's disconnect. So the behavior is different. Programming-wise, it's gonna also be different. Programming-wise, because the behavior is different. Programming-wise, it's gonna be also different. I'm gonna tell you how. Is that okay? So now let's talk about this one. Number 1, as I said before, number 1, I'm gonna tell you how it is connected. Number 2, I'm gonna explain how can you use it. Okay? The way it is connected, last time I told you, this is how we connect the switches. So this is 5 volt. So it means so this is port H. For example, if this is PH0, this is how we connect the switch. We have here high resistance. Okay. And here 5 volt. And then we have a switch. Okay. And then we have a small resistance here. I'm gonna say it's short circuit. Like something like short circuit. Is that okay? Okay. So this is how the switch is connected. That's why I told you if it is open, you put here 5 volt. If it is closed, you put here 0 volt. Okay, this is how it is connected. Okay, now where are the push buttons and how they are connected? I'm going to tell you how. Okay, again, the people who created this board is used for education. This board is used for education. That is why they put a lot of stuff here. Okay, so the way they did it, we have four push buttons. They are connected to port H as well. So 4 pins on port H. So port H, Port H should have 8 pins. Okay, guys? The first 4, PH0 to PH3, every pin, there are a switch plus push button. But from PH4 all the way to PH7, every pin should have only a switch. Okay, guys? So let me say it again. For port H, we have 8 pins. Okay? PH4 to PH7, everyone here, there is only switch. Only switch, all right? But the first 4 from PH0 to PH3, every pin, there is a switch and the push button. Is that okay? And you should use one of them. I cannot use both of them at the same time. Is that okay? Again, if you ask me why they made this way and in your capstone, should you do the same thing? My answer, no. In your capstone, you should not do the same thing. In your capstone, they did it this way again because this is used for education, right? So they want to put too many stuff, right? So maybe in one project, I need to use 4 switches. In one project, so I'm going to use all the switch, I'm not going to use any push button, right? In some project, I need 4 push button. So here in the first 4, either use the push button or use the switch. You cannot use both at the same time. You have only one of them. Is that okay? Anyway, but if you do your own capstone, usually you are not going to do this way, okay? Because in your capstone you need a switch all the time. So you're not going to put switch and switch. You're not going to put switch and push button at the same time. You're not going to do that. Okay. So anyway, so the way it is connected is as follows, guys. So here they get it from here, and this is the push button, and this is the ground. Okay, guys. So this is how the hardware. This is how the hardware looks like for the base from PH0 to PH3. This is how the whole hardware. But from PH4 to PH7, this is how the hardware looks like. Is that clear? Any question? Okay, guys, any question? Is that clear? Okay. So here we have only 4 push buttons. They are connected to the PH0 to PH3. Okay. So you have to use this one or this one. Is that okay? Any questions? Okay. So number 2, tell me what is the difference between the switch. Very important to understand it because it's going to have impact on the programming. So you should understand what is the difference between a switch and between the push button, because the programming is going to change. The programming is going to be different. Is that okay? For the switch, guys, if the switch, let me write it here. So for the switch, so if the switch is off, okay, so it's going to be high, 5 volt, okay? It's going to continue. So if you want to turn the system off, it's going to be 5 volt, or the switch is disconnected. Or the switch, let me use open and close. If the switch is open, it's going to be 5 volt. At this moment, you make the switch close. You close the switch, so it's going to be 0 all the time. Is that okay? Until, okay, let me make it in another one because this is very important. So very important to understand how the switch works and how the push button works, because this will make programming different. I'm going to tell you about, okay? So for the switch, if it is open, if the switch is open, so it's going to be 5 volt, right? And then at this moment, you decided to close it. Once you close the switch, so it's going to be 0. It's going to be 0, okay? And here the user is going to open it again. So it's going to be high. It's going to continue this way until you close it. Once you close the switch, it's going to be 0 and so on. Is that okay? So the switch has 2 positions. One position closed, one position open, one position is 5 volt, one position is 0. Okay? Okay? The switch is not going to change from volt to another until the user do it. You got what I'm saying? So, but the case is different in case of push button. In case of push button, it is all the time 5 volt, all the time. Once I press, it's gonna go low, this way, okay? And it's gonna continue low. Once I release, it's gonna go high again. So once you press and release, here you hold, okay? So it's gonna, all the time it's high, so that's how it is. Once I press, so every time I press, I'm gonna generate a pulse, this way. Once I press, right? Because this is how the circuit is. The circuit was always, so if you look at the circuit here, forget this part, I'm not gonna use this one, so forget this part. So you can see all the time it's 5 volt. All the time it's 5 volt. Once I press here, I'm gonna make it 0 volt for some time. Once I release, it's gonna return back 5 volt. Is that okay? So anyway, so this is how the switch behaves. This is how the push button behaves. Okay, you can see. Any question? Okay, guys, any question? So the question is that how you told us this can make the programming different. Yes. How? I'm going to tell you how this can make the programming different. Okay. The reason is here in case of switch, I have 2 positions. Open or closed. So I have 2 positions. I can consider one position on. For example, if I want to use the switch to turn the system on and off, so I can use one position for on. So for example, 5 volt, I'm going to consider this system on, and 0 volt, I'm going to consider the system off. That's it. So one position for on, one position for off. Is that okay? So if I want to know if the system on or off, all what I have to do, and I want to see what is the voltage here. If the voltage is 5, that means the system has to be on. If it's 0, the system has to be off. So it's a very easy case, right? Any question? Here, it is different. The case here is different. Why the case here is different? Because all the time it is 5 volt, all the time. It just is going to go to 0 just at the moment you press. So how I can know if the system is on or off? How? Right? So the case here is different. I'm going to tell you how. The way you have to do it, guys, is the following. You have to use a variable. This variable, okay? I have to use a variable. This variable should have 2 values. One for on, one for off, okay? In the very beginning, I'm going to assume I'm off. When you press the button, I'm going to change the value to on, right? So I'm not gonna go and check the voltage. So in case of the switch, if I want to know the system on and off, you can go and check the switch, right? But in the case of push button, no, I'm not going to do that. Because if I go and check, I will find it if it is on or off, I'm going to find 5 volts, right? So the way I'm going to do it, I'm going to use a variable. This variable has 2 values. In the beginning, I'm going to assume this variable has off. You press the button, I'm going to change the value to on. You press the button, I'm going to change the value. And every time you want to know the system is on and off, I'm not going to come here. Like here, I'm going to go to here. Here, I'm not going to come here. What I'm going to do is, I'm going to ask the variable. You got what I'm saying? Are you on or are you off? You got what I'm saying? You will see right now how I'm going to do it in the program, but this is the main idea. So the main idea, I'm going to use a variable. This variable, for example, should have 2 values like 0, 0, FF. In the very beginning, so one value I'm going to consider the system has to be off. One value I'm going to consider the system has to be on. In the very beginning, I am here. And if you press the button, I'm going to come here. If you press the button, I'm going to come to here. So every time you press the button, okay, so I'm going to change the value of the value. And if you want to know the system on and off, all what you have to do is just have to check the value, not this one. Okay. Any question? Let me tell you the conclusion in just one sentence. Okay? Now, look here, guys. The problem is, in case of switch, I have 2 volts. Right? It's a switch has 2 positions. One position is going to give me 5 volt. The other position is going to give me 0 volt. Okay? So I can consider one position is the system should be on. The other position, the system should be off. Is that okay? And if I want to know if the system on and off, all what I have to do, like that's not what I did right now in the program. The program I explained right now. All what I have to do is I have to go and check the voltage. If the voltage is high, I'm going to put it on. If it's zero, I'm going to put it. That's it. Okay. In case of push button, the story is completely different. Because the push button, it's all the time, it's 5 volts. So if the system is on, it's 5 volts. If the system is off, it's also 5 volts all the time. Because the user is gonna press just for few seconds, just to press and release it, pulse and release it. Okay? So the way in order to know the system on and off, I'm gonna use a variable. So if I want to know the system on and off, I'm gonna ask the variable. The variable should have 2 values. One variable on, one variable off, one variable on. Okay? And then, so the next variable should have one of 2 values, this variable. So if I want to know the system on and off, okay, I'm going to ask the variable. The variable is going to tell me. Is that okay? And every time you press, I'm going to switch. From if I zero, I'm going to go to okay. If you are I'm going to go to 0. Any question? I'm going to show you how can you do it in program right now, in a program. Any question? Any questions? Okay. Very important thing. Listen to me, please. This is another thing before I give you a program. Very important thing. I'm going to tell you what happened one time. One time, student wrote a program, and he told me, look, it's not working. I press a button, nothing happens. I looked at the program is good. Everything is right. The program is correct. What was wrong? I'm going to tell you what was wrong. Listen to me. So one time, one student wrote a program. I looked at the program. Everything is okay, but when I press a button, it does something. But it doesn't do what it's supposed to do, right? So the program is correct. You know what was the problem? The problem was he forgot this switch was connected. Okay, the switch was so this was 0 volt all the time. So if I press the voltage, if I press the button, it's not going to have any impact because this is 0 all the time. You got what I'm saying? Because you connected this one. That's why this one has no impact. The push button has no impact because it's 0, and there is no way to know where the 0 volt is coming from. There's no way. Okay. So what I want to say is that if you want to use the push button, you have to make sure the switch is open. If you want to use the push button, you have to make sure the switch is open. Is that okay? Because if the switch is connected, you are going to put 0 volt here, so this one has no impact. This one is not going to create a pulse, as I told you here. So every time you press, you are not going to get a pulse like this. Any questions? Is that okay? Okay, guys? Any questions? Okay. Now, I'm going to explain now. I'm going to repeat the same program. I did a program. How can you use a switch to turn the alarm on and off, right? I explained this program. Now, I'm going to repeat the same program, but using the push button. So I'm going to explain the same program, but using how can you use a push button for on and off. Okay? And I'm going to use a variable as I told you. So I'm going to show you this program first. Yeah, here. Look here. So this is the program. Look here, guys. So this is the buzzer. You remember what I did before? This is the program. This should be 1 second. After 1 second, I have to go to the beginning again to check if the system is on and off, right? If so there should be something at the beginning here. I have to check. If the system is on, I'm gonna come this way. Okay, so let me make it a bit better. So there should be something here in the beginning. If the system is on, I'm gonna come this way, right? To do 1 second, and then I'm gonna come back. If the system is off, I'm gonna wait if it is off. That's exactly what I did in case of the switch. So before, this is alarm. So before I run the alarm, I'm gonna put something at the beginning. I'm gonna check if the system is on, come this way, and then come back to check again. If the system is off, we have to wait. That's what I did in the switch, and that's what I'm gonna repeat again, but for the push button. Okay, let's see how I did it in the push button. Okay. This is a configuration. I shouldn't talk about this one. This is just a configuration, as I told you multiple times. So yeah, so this is the beginning. So here, this is the part I wrote it here. Look, it's somehow a little bigger than what I did before. So this part should check. So this part should check if the system is off. So I have to keep looping here if the system is off. If the system is on, you have to come here to execute 1 second and come back. Okay. Let's see how it works. But the way I did it, guys, as I told you, I'm gonna create a variable. I'm gonna call this variable on off. Just in name. So I'm gonna create a variable. As I told you before, this variable should have 2 values. One value I'm gonna consider it off. One value I'm gonna consider it on. Is that okay? And every time you press the button, I'm gonna change it from this value to that value. Is that okay? You can use any 2 values. You can use any 2 values. But maybe it's a smarter idea. Maybe it's a smarter idea to use 0, 0 and FF. Why? You got what I'm saying? So what I'm saying, you can use any 2 values, 0, 1, 7, 8, any 2 values. One value I'm gonna consider it on, as other value I'm gonna consider it off. But maybe it's a smarter idea to use 0, 0 and FF. Yeah, okay? Why it is a smarter idea? Because it's very easy to move from here to here and from here to here. Very easy. You just use complement. You got what I'm saying? So every time, so have a variable, every time you press a button, I'm gonna complement this one. Once I complement, you are gonna move from 0, 0 to FF. You press a button, I'm gonna complement so that I can move from FF to 0, 0. Just smarter. Easy way. Otherwise, I need to check. So if I don't use these 2 values, I'm gonna check. If you are 7 and I press, please make it 8. If you are 8 and I press, please make it 7. So it's gonna be too complicated. Or this is smarter, just smarter, because you are gonna put 0, 0 and FF. So every time I press the button, I have to move from one value to another. The way I'm gonna do it, every time I press, I'm gonna complement this value. Is that okay? That's why I selected these 2 values. Okay. So let's see how this part is gonna work. For sure, it's more difficult. It's not more difficult, but you have to write more code in case of the push button. That's true, because in case of the switch, just very trivial. So let me go back. Just I wanna choose a comparison. In case of switch, it's just one command, right? It's easier. In case of switch, it's easier. Because in case of switch, you just go to check the voltage. The voltage is 0 or 5. That's easy. But in the push button, no, somehow you have to write some more instruction. That's what I'm going to show you. Okay. So here, okay. So here, look here, guys, how I did it. Number 1, I have to check the pin, right? Do you press on the pin or not? So now there are 2 cases. Do you press on the pin or not? If you don't press, if you don't press on the pin, okay, that means I'm not gonna change the status of the variable, right? That's what I did. So now I'm gonna check, okay? Look here, guys. If it is 1, if it is set, that means the user did not, so the user did not change the status of the system. So I'm gonna go here to start. In start, I'm gonna check the steps. I'm gonna ask the variable, this variable. Is the system on and off or off? It's gonna tell me, okay? That's what I did. So number 1, this is the first case. The first case, when I check the pin, I thought it's 5 volts. That means the user didn't press. So that means you did not change the status of the system. So I'm gonna come here to ask the variable, to check the variable. Okay? If the variable is 0, okay, that means the system is off. Okay, so if it is 0, that means I have to come here because the system is off. Come here. Otherwise, come here because the system is on. Is that okay? So case one, the user did not press the button. This is case 1. In this case, I need to know the system is on or off. Okay, who's gonna tell me this variable? So I'm gonna come here to check. If this variable is 0, that means the system should be off. So I'm gonna come back. I'm not gonna go here to run the button. Okay. Otherwise, I'm going to go here to run the button because the system is on. Okay. Now, if you press the button, so now if it is 0, so if it is 0, that means you press the button. If it is 0, that means you press the button. It is 0. Okay. So in this case, I'm going to complement the variable as you see it, because I'm going to change the status of the system because you press the button. So now I'm going to change the status. So I'm going to read on off, then I'm going to complement it. I think there is easier way. I think I overcomplicated. I think we have already a command called com on off, right? I think I can do this way, right? Because we have instruction to complete memory location. So I can do this way if you want. But anyway, okay, guys. So here I'm gonna change the status of the system, and then here, see what I did here, guys. I'm gonna wait until you release. So I'm gonna keep looping here until you release. So what I'm gonna do, look here, guys. So once you press here at this moment, I'm gonna change. Let me delete everything. So once I press here, number one, you have to complement the system. You have to complement the variable. This number one. Number two, I have to wait until you release, until it becomes high. So I'm gonna keep looping here until you release. Is that okay? I'm gonna wait until you release. Any questions? Why? Why you have to wait until I release? Because every time you press the button, I have this one should be, I have to make only one complement, right? It's one press. If I don't wait, maybe I'm gonna come here, okay? I'm gonna change the system from on to off, and then I come here to check again. If I'm still zero, okay? So I'm gonna change again from off to on to off, so on, right? So I have to wait because once you press, I have to change the state of this only one time. So that's why I'm gonna wait until you release. Otherwise, if you don't wait, the program is gonna come here, take some action, and then maybe it's gonna change. So I wanna hold the program here. I wanna wait because I have to only every time you press, I have to toggle or I have to complement the variable only one time. Okay? Any questions? So this part here. So once you come here, number one, here we're gonna complete. Number two, I'm gonna wait until you release. Once you release, I'm gonna come here to check to see if the system is on and off. And then if it is on, I'm gonna come this way. If it is off, I'm gonna come back to this way to check it. Is that okay? Any question? Okay. So I'm not sure if I have the same. Okay. So I have the same program. No, that's something else. Okay. I don't think I have the same program in C, but still you can do the same program in C. Okay. Okay, you can do the same one in C. It's not difficult. It's the same way. Okay. Any question, guys? Okay. Any question? Okay. Let's tell you the last thing I wanna teach about push buttons. There is a problem in push button. It's called bouncing problem. So mechanical, because this is a mechanical device. This push button is a mechanical device. Okay. So a problem in mechanical, and I'm gonna tell you what I mean by the word mechanical push buttons. I'm gonna tell you what I mean exactly. Okay, this problem is called bouncing problems. Very interesting. I'm gonna show some video, very interesting video. It's called bouncing. You know bouncing? When you bounce, bouncing problem. Okay, why you call it bouncing problem? Okay, I'm gonna tell you why it's called bouncing problem. Number one, define it. Number two, tell me why it's a problem. Number three, tell me how can I solve it. Okay, so definition, what is the problem? Number two, why it is problem. Number three, how can we solve it? Okay, so let me tell you how it works. Okay, as you know, this push button has a spring, mechanical spring. So it has something like a mechanical spring, right? So once I press, and it has some kind of contacts. So this two mechanical contacts, right? So what happens is that because of the spring, this is something it's out of our hands. This is nature, by nature, right? Because it's a spring. What happens is that you think if it's open, right? Once I press, it's gonna connect right away. No, it's not going to work this way. What happens, because it has a spring, it's going to do some bouncing, okay? So this is exactly how it works, okay? So for example, it's open, when I press, it's not going to contact this way. No, it's going to make some bouncing, and then it's going to, before it reset this way, or remain this way. So it's going to make some bouncing. Is that okay? This is because of the nature of the spring. You got what I'm saying? So I told you before what it means. Okay, it's still bouncing. So what it means? It means, this is what I told you before. When you press and you hold and you release. Okay? This is if the switch is ideal. Okay? Actually, it's not like that. Actually, it is not like that. Okay? Because here I'm saying you can turn from off or on to off, okay, without bouncing. Actually, should be something like that. In reality, this is the reality. The reality is there should be some bouncing here before it becomes zero. Same thing here. There should be some bouncing before it is high. Okay, this is how it is, and this is coming from the mechanical parts of the switch. This is how it is. Is that okay? So this is a definition. You understand the definition of the problem, the bouncing. I didn't explain yet why it is a problem. I didn't explain why why you can solve it, but just I'm making a definition. So the way I told you, when you press a button, it's going to be something like that. In reality, no. It has some mechanical parts. But the switch is not going to move right away. The switch is going to be some bouncing before it opens because of the spring, mechanical part is something like that. So this is how it goes to the edge. Okay? So this is the bouncing. So why it is a problem? I'm going to tell you why it is a problem. Okay, guys? It's a problem because the way I made the program, I made the program every time there is something like that. So I'm going to take it like you pressed one time. So if you just do something like that, this is another press. So the program is going to take this way. Every time I found something like that, you press. So I'm going to take action. You press, I'm going to take action. So every time I see something like that, that means I press. What happens is that you press only one time. You actually press one time. But because of the bouncing, microcontroller is going to assume you did one press here, one press here, one press here. So you only press one time. So I have to, the program has to take action only one time. You understand? So every time I press one time, you have to take action one time because it's one press. Okay? But actually, because of the bouncing, your program is, you press one time, but your program is going to behave, or your program is going to take 3 actions, 4 actions. Like your program would think you press 3-4 times. Is that okay? For sure, this time from here to here is a very little time, 10 milliseconds or 15 milliseconds. Very little time. There is no human being can make 3-4 presses in 10 milliseconds. You got what I'm saying? So this is the problem. The problem again, what's the problem again? This period is bouncing about from 10 to 15 milliseconds, 15 milliseconds. Okay? There is no human being that can make presses that fast, right? 3-4 presses every 10 milliseconds. We cannot do that, right? So number one, I made the definition. We have something, it's called bouncing. This bouncing, it happens in case of mechanical switches, okay? Another thing is, I explained the problem. What is the problem? The problem, all what I need, like we all see a very interesting program. I want to press one time, you shift the LED one time. I want to do something like that. Every time I press one time, I shift the LED one time. Okay? I want to do, so you will see, I'm going to show you a program. You will see, when I press one time, the program is going to take it like you pressed 3-4 times. It's going to shift it 3-4 times. Okay? Because this bounce is that is because our microcontroller is too fast. So what's going to happen? Microcontroller is too fast. I'm going to check here, and then I'm going to run the program. I will check here. I will find it's another 0. I will run the program fast. I'm going to come to here and check another 0. So every time I see a box, I'm going to consider you press one time. Is that okay? So your program is, again, so what is the problem? In one sentence, the problem is that when I press one time, I want the program to take one action. But because of the bouncing, When I press one time, my program is gonna consider it like you pressed 3-4 times. Okay. How can we solve it? There are two solutions to this problem. One of the solutions that we are gonna do, we call it software solution. It's a very simple solution. Just give me 1 second. We have a solution we are gonna do. We call it software solution. This solution, what we are gonna do, look here, guys. Every time you press, I'm gonna wait 20 milliseconds to pass this period. So every time you press, I'm gonna hold the program for 20 milliseconds so that I pass this one. And then I'm gonna write this instruction to wait until it is high. So I'm gonna use this instruction. This one is gonna wait until you release. Once you release, I'm gonna wait another 20 milliseconds. Is that okay? So if you use this instruction, every time you press one time, I'm gonna take action only one time. So every time you press, I'm gonna wait 20 milliseconds. If I don't wait, my program is gonna run. It's gonna take another 0. It's gonna take another 0. So I'm gonna wait 20 milliseconds, and then I'm gonna wait until you release, until this one is out, as long as 0. And then I'm gonna wait another 20 minutes. This is called software solution. So every time, this is what we call software solution. Every time you use the switches, you can use this code. That's what I'm going to explain next time. Okay. So Friday, you are going to have the last quiz on stack and subroutines. Okay.